Hello, I'm Joel Abhishek Pira, and I'm joined by Ranjit Tarin and Arsis Panda. Together, we developed a diabetes risk assessment tool using AWS. This project holds deep personal significance for me. A few weeks ago, during a routine checkup, my mother was diagnosed as pre-diabetic. It was a wake-up call for my family. It also highlights how crucial early detection is and how small life changes can make a significant difference in preventing diabetes. This experience inspired us to create a tool that empowers people to understand the risks, their early risks. Our application uses machine learning to analyze various risk factors and generate a personalized risk score and provide a tailored health recommendations of them. Okay, our goal is to enable proactive steps towards better health and to help others avoid the challenges of undiagnosed diabetes. As you see, this is the app we have created, diabetes risk assessment tool. As on the left-hand side, we can see all the different parameters that the app intakes. For example, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes peripheral function, age, and models. We have two models to choose from. One is the logistic regression model, and another is the random forest model. These data you have seen is the training data basically, and the visualizations of it. Right now, the model says it's 79% accurate of declaring that you're diabetic according to this. If we lower it, you can also see that it goes to you're healthy as well, right? As you can also see that we have an option to download the report, which downloads the report from the diabetes mode and will show you where you can improve and where you can't. Now, to know further about how the AWS is implemented, I will call upon Arsis Manpanda.
So we've used AWS SageMaker to host our ML notebook. SageMaker is a cloud-based service which provides us tools to deploy and run ML notebooks smoothly. It provides us with distributed and scalable GPUs, as well as TensorFlow, PyTorch, and sklearn and other tools to help us in creating an ML notebook. Now, as you can see here, I've created a diabetes instance to host our ML notebook. Now, this instance is actually an EC2 instance. It's running as an EC2 instance. All the instances in SageMaker will run as an EC2 instance. Our notebook uses a diabetes CSV dataset to train itself. Now, this dataset has been uploaded by me on an S3 bucket, which is directly connected to SageMaker, as shown in the ML code, which will be later. So if we choose to use another dataset, if we choose to use another CSV dataset, then we can just upload it on this S3 bucket, and AWS Lambda will trigger the code to rerun on the new dataset. Hence, the website will always show stats based on the latest dataset. The AWS Lambda is basically working to integrate SageMaker with S3. For SageMaker, we've also used a dedicated subnet to isolate all the resources used in one subnet, as well as to provide privacy, as well as integrate AWS Lambda and S3. Now, if I'm running the diabetes Jupyter Lab instance, and this is basically the code. For more details on the code, I'll hand it over to Ranjit.
Now moving on to the code, we first import all the required libraries in the first part of the code. These include libraries for data manipulation like Pandas, NumPy, machine learning framework like scikit-learn, and visualization tools like Matplotlib, Seaborn, and Plotly. Additionally, we also import Boto3, which is the AWS SDK for Python. It will be later used to interact with AWS services, including S3, where we have stored our dataset in. So, in the next part of the code, we'll be accessing the dataset that is stored in the Amazon S3 using Boto3. And after that, we will be just displaying the dataset overview and visualization using Streamlit. We display the descriptive statistics of the dataset and a bar chart for an overview. After that, we just prepare the data for model training. The data is split into testing and training sets using train test split. In this code, we are splitting the dataset to 80% and 20% train test split. We also standardize the input features using standard scalar to ensure that all the variables have the same scale, which improves model performance. So after that, the next part of the code allows users to provide feature values like glucose, BMI, and age in form of uh, sidebar interfaces. So as shown in the demo previously, the user can use the sidebar to change the values for change the input values, which will later be collected into a data frame that will be used for the predictions through the model. So this application supports two machine learning models, random forest and logistic regression, based on the user's choice from the drop-down menu. Either a random forest classifier or logistic regression model is trained using training data. We also display the confusion matrix classification report and the random forest. For the random forest, we also display the feature importance as shown in the demo previously. Finally, predictions and recommendations are made based on the user report. The app finally predicts whether the user is diabetic or not and displays the result. If the prediction is positive, meaning the person is diabetic, then it provides recommendations for managing the health. So, in conclusion, the project demonstrates a seamless integration of various AWS services, such as S3 for data storage, SageMaker for machine learning, EC2 for scalable compute power, and other such AWS services. By leveraging Streamlit, we have also created a user-friendly interface for data visualization, model training, and prediction, making it accessible to both technical and non-technical users. Thank you for your time and attention.